Well, we're starting to get back into that active weather pattern again, finally. September has been kind of a quiet month here. And so we've got a few towers out and about. These ones right here are just south of Dallas, near Waxahachie. So a little bit of color in the sky this evening. Hope you all are having a good evening, Saturday the 24th here. And this is the surface analysis here from SPC. And we can see one little trough out ahead of the squall line here, and another behind it. So that tells us outflow boundary. So we can just fill that in. And there is an outflow boundary back behind these lines of thunderstorms because there is outflow, and that flows away and towards the northwest, and even got a little bit of precip on the backside right here near Dodge City. And underneath the squall line we have a meso high. See how the isobars kind of curve southward like that. That's high pressure underneath, caused by all the precipitation and cool air that's in this squall line itself. And that was one of the very first things that they identified in the thunderstorm project back in the 40s when they first did a investigation of thunderstorms with measuring equipment. They found that meso high. So it's a very key part of the thunderstorm structure. Elsewhere ahead of the line, we are under a south, I'll call it south gradient, giving us southeast winds from the Gulf. So that's going to be changing here very shortly. So why do we have all these thunderstorms? We can check on the sounding. And what we notice here is we have a steep lapse rate area. See how the temperature line is leaning way over to the left? That's showing we have cold air above warm air, and that is an unstable profile. And we also got a pretty good bit of moisture here in the lowest 2,000 or 3,000 feet of the atmosphere. So if we construct our lifted parcel, it's going to look something like that. So that's going to be about 2,000 cape right there. It's enough to support a few isolated thunderstorms here and there. So let's look at the big picture with digital atmosphere. And every day I've been showing you the streamlines because that's one of the key patterns that dominates the weather. You know, we always think of pressure and highs and lows, but that's manifested by the flow of air. And so we can easily see low pressure areas, like there's one here in the Oklahoma Panhandle, another in very far southeastern Saskatchewan. And that also outlines fronts, so there'd be one right there and one right there. And you can see that this Great Plains system is split into two parts. So they're kind of like two separate systems. And then the main flow back behind the southern system is through Nevada. So we should see reflections of this in the West Coast charts. So we'll just pull those up here. So this is a plot of the last hour's data, and you can see in the tropical sector we've got lots of mid to upper 80s, dew points in the 60s, so that's slightly on the dry side for this time of year. And then we go out west behind the cold front. Now you can see that northwesterly flow. So Las Vegas there, even though they're 88, they've got northwest winds. So there's been a lot of modification of this Pacific air as it's come inland. There's been some adiabatic heating on the backside of the Sierra Nevadas and the coastal range. Same thing in the San Joaquin Valley. It's got deep northwesterly winds, but they've had a bit of that adiabatic warming. 96 degrees there at Redding, and I guess that's either Redding or Red Bluff. I'm not sure which one. So let's see here. Maybe I'll bring up the polar orbiters. That's always kind of fun to look at because it's so colorful. Let me see how the stream is doing here. I decided to do 30 frames per second to make it look a little bit sharper, and I've got a yellow bar here. I don't know if you can see that right there. There's a yellow bar. It's telling me that the stream health is marginal. So if you're seeing any gaps or anything like that, any gaps in the audio, let me know, because I can always kick it back down to 24. Wish I had faster internet here, but that's the next tier of service is about $200 to $300 a month. So we're not. Maybe when the stream is busier, we can think about that. So here's that system coming through the plains. I'll add the state outlines, and you can see pretty large dry slot coming down the south side. So the main baroclinic focus is out in the low plains, so places like Iowa, Kansas, Texas. This is the area for cyclogenesis. Anything back further west, that's more of an occluded area. It's kind of detached from the warmer air coming from the Gulf. It's like a really nice day out there in the western U.S., even though I've been on the warm side. You can see so much detail on here. It's really amazing. Okay, let's see. Let's go to the forecast here. This is the North American model, NAM. So this is basically the WRF. And so what we want to look at is to see if there's consistency between this and the radar. See, we've got precipitation on here. And it's showing for 0Z a line basically from Des Moines to Chanute, Kansas, to Oklahoma City, and to Abilene. So does that match the current data? This is what we call initialization of the models. Verification of the initialization, I guess you could say. And yeah, there's Des Moines right there. Topeka, not quite to Chanute, so the model may be running just a little bit fast here. And sometimes you will get some very significant errors. So let's see what the NAM is going for here. Run it to tomorrow. It's got the squall line moving out towards the Chicago area, and then it kind of breaks up there tomorrow morning. And we're not seeing much eastward progress in Texas. It kind of, a lot of the precip kind of hangs around the higher elevations like Cap Rock, West Texas. Can't quite get that precip out here. There is some precipitation that does form in the warm sector. That's what we call warm advection precipitation. It tends to be kind of spotty or embedded. And I'm not quite sure if that's going to pull together, but that could be a possibility for tomorrow. Maybe some stuff out ahead of the main line, especially if we have upper air support coming in. But it looks like not really any squall line coming through DFW or Austin or Little Rock. And the front basically just comes right through, almost dry, on a Sunday night. So I'm not sure how we're looking as far as heavy precipitation across much of the south central U.S. Looks like it's going to be pretty spotty there if this pans out. But however, in the Midwest, yeah, it definitely does look like rain from Monday, and this is Monday night here, so I know we have one viewer in New Hampshire, so that's going to be coming through, it looks like, Tuesday morning. And let me just draw the front on here so you can kind of see that. So that's the front moving through. I'm not quite sure where the warm front is, probably up here in Maine or Ontario. And if we wanted to kind of focus on Texas and see really what we're looking at, we would look at the high-resolution rapid refresh model. That's at rapidrefresh.noaa.gov. And let's see how that model's doing. Okay, we're showing 8 o'clock here. This is 1Z. And does that look reasonable? Yeah, that looks pretty close. So moving forward, it looks like around 2 in the morning it gets close to Dallas but kind of breaks up, and it just kind of hangs around the Oklahoma City, Childress, Abilene area. So this is kind of what we call training of cells. There's probably a very strong southerly component to the upper level flow. So we're getting cells kind of moving over each other in a line. So we're probably going to see maybe some flash flood watches out there tomorrow, but not much for east of I-35, looks like. Okay, so let's move ahead into next week and look at the GFS. And I will tell you the GFS is a little bit off. Let me show you what the GFS did here. This will show you an example of where it kind of fails. So we'll wait for these charts to come up. Yeah, you see right here down in Texas, this is 0Z, so this is 1 hour ago. It's got the line basically from Emporia to just west of Wichita to West Oklahoma and to Childress. And we know the line is actually out here. So this model did not initialize very well. So that can have an effect on the accuracy later, but the main dynamic systems will probably be pretty close. So we can continue using this for the medium range forecast. So what we see is a big push of dry air southward through much of the U.S., like that. You can see it sweeping those higher precipitable waters south. So things should get a little bit mild here over the next week across much of the eastern half of the U.S. Then we start getting a little bit of return flow. This is going to be next weekend. This is quite a ways out. And you remember we were talking about that hurricane coming in. Yesterday the model was thinking maybe south of Cuba and then coming on shore near Houston, Lake Charles, and then I showed you some of the other components, some of the other initializations of that model, some other runs, and it was showing that we had a couple of different solutions, one hurricane going into Florida, another into Mexico, and some of them were predicting nothing at all. So the best solution we have right now, they're bringing a hurricane into Florida now. So this is a lot of change from the model, from run to run, but this is 280 hours out. So this is not going to really start getting solid until maybe 4 or 5 days from now. And then we can start thinking about, where this thing is going to come on shore and who's going to be under the gun. Should be interesting. We should see something going on hurricane-wise after next weekend. And that'll be the big thing here. Somebody asked about pivotal weather. I haven't used that. So there's a lot of different sites to look at. I'm going to probably try to go through some of those when we start getting some hurricane action. I'll bring some of those sites up. And you probably know what feature is coming up next. I did not prepare for that. Give me just a second here. Let me just throw this up really quickly so I can get my panels all set. Okay, I think we're good here. Yes, it's that time to look at some geography. Because geography is one of the keys to weather forecasting. I think that would be the second thing you'd have to be an expert in. Some people would say math, but I think geography is more important. So what does this look like here? It looks like maybe Nebraska. Maybe you can figure out any guesses what this is. Looks very desolate, doesn't it? Kind of reminiscent of the Great Depression. Looks like Little House on the Prairie there. You think Laura Ingalls is going to come bouncing out of there. So very scenic there. So any ideas what this is? Here's a look overhead. So let me zoom back a little bit. So you're probably thinking the plains, but there's some of these canyon lands. That's kind of unusual. Let me zoom out a bit. Washington. Bet you never knew that existed in Washington. You know, you think of like the coastal range and big redwood trees and stuff like that. Well, maybe not redwoods that far north, but yeah, they actually do have prairie land out there, believe it or not. And let me show you some of the precip out there. See this big precip shadow out over the interior. And this is being caused by adiabatic warming and drying of the air as you get the prevailing flow moving west to east across the mountains. Because we've got two mountain ranges here. One is the part of the coastal range. I'm not sure exactly what that is. It's Mount Olympia or something like that. I can't remember the name of the range, but there's another one here just east of Seattle. So we actually do get a bit of a rain shadow right around Seattle itself, Seattle-Tacoma, and an even bigger one inland. And the precip in there, right in there, is going to be about 10 to 20 inches. So that's kind of like West Texas there. So I'm going to call that more kind of along the lines of trivia, just kind of some neat stuff there. So don't get too drawn into the stereotypes of weather in the Pacific Northwest, because there is a lot of variability there. Okay, let me move over to our models, and we'll just check out very quickly out in the Atlantic. Carl is moving finally to the north and recurving out there, and I think Lisa is going to do the same thing. This is what we're watching here southwest of the Cape Verde Islands. That's pretty far south. That's at about 9 degrees north. So that's got a pretty good chance of moving into the Caribbean. And the 5-day outlook. Anything in the Caribbean has got a fairly decent chance of getting into the Gulf of Mexico, and that creates problems for the U.S. So we may have a bit of a active pattern. This will be around October 6th or 7th when it gets up there. Okay, I think I'm probably done here. Yep, I'm done. So we will probably have a little bit more action for tomorrow as that front sinks a little bit further to the east and south. And I will see you at the usual time, 8 o'clock. Thanks for watching. And, oh, by the way, I'm going to try to sign out with a little bit of footage I took just before I went on the air. It's the sunset, and you will hear a little bit of the wildlife. So if you want to, you can watch that and turn up your speakers. So let me get that going here, and I will sign out my microphone.